a solid, heavy bar of 99.99% pure metal. But today, there's another kind of gold people talk about.
Real gold begins in the earth, deep underground, locked inside rock for millions of years. Mining companies blast and dig massive amounts of ore.
Bitcoin's raw material looks completely different. There is no rock, no physical ore, no shiny metal.
To turn mixed material into 99.99% pure gold, the refinery has to separate gold from everything and golds.
The goal is strict, 99.99% purity, often called 4 nines fine. That means
For Bitcoin, refining looks like math. Miners all over the world compete to solve a cryptographic puzzle.
Once the gold is refined to 99.99%, it's time to give it a shape the world recognizes.
After cooling, the bars are cleaned, sometimes polished, and then stamped. On each bar, you'll see the refiner's logo.
Bitcoin's final form isn't a bar. It's a digital unit recorded on a global ledger. When a bar of gold is finished, the biggest question is, where do you keep it safe? The answer? Vaults. Bank. So what does 99.99% pure really mean in both worlds? For gold, it's scientific. You can melt it, test it, and
A bar of 99.99% pure gold and a string of code represent.
both are shaped by the same force, our belief in value. One melts under fire. The other is secured by math. But which is truly stronger?
To answer that, we follow two journeys, from raw chaos to perfect purity.
This is how a bar earns the mark, 99.99% pure.
And this is how a digital coin earns its trust, through cryptography and consensus. Two worlds. One question. What does it really take to make gold in the modern age?
Natural gold was forged in ancient stars and trapped deep within the earth.
Miners hunt for tiny traces of it inside ordinary-looking rock.
Bitcoin, by contrast, was created in 2009 as a purely digital ledger called a blockchain.
Its origin is not geological, but mathematical, described in a 9-page document.
Where gold is rare because nature made it scarce, Bitcoin is rare because code makes it scarce. Its supply is capped forever at 21 million units. Gold deposits, in contrast, are scattered across continents, discovered and exhausted over centuries.
From here, the two journeys could not be more different.
But both are races against time, cost, and competition.
First, we follow the ancient path, turning rock into 99.99% pure gold. Gold mining begins at a brutal scale, shifting mountains to find a few grams per ton.
Ore is blasted, crushed, and loaded, hour after hour.
Teams drill deep holes into the rock, planting explosives with surgical precision. Each blast breaks open new layers of ore and scars the landscape a little more.
Underground, the work is darker, tighter, and even more dangerous.
Modern mines are guided by screens and sensors, not just shovels and luck.
Millions of tons of ore will move before any gold bar is ever poured.
But every ounce of gold leaves a footprint on the planet. Behind each bar of gold are human stories of risk, pride, and fatigue.
Now the ore faces its next trial.
the refinery. First, the ore is ground down, turned into powder to free the gold inside.
It looks ordinary, but inside this dust are particles worth a fortune.
Chemicals are added, bubbles rise, and gold-bearing minerals cling to the foam.
The valuable concentrate is skimmed away from the waste. Inside the refinery, another transformation begins. Fire. Concentrated ore is smelted at extreme temperatures, separating metal from impurities. This stage creates a rough metal mixture, still far from 99.99% pure. The metal is cast into anodes, ready for an even more precise process. Electrolytic refining uses electricity to strip impurities away at the atomic level. Pure gold atoms leave the anodes and grow on the cathodes, one layer at a time. What emerges looks crude, but its purity is already astonishing.
These crystals can be refined again, chasing the elusive 4/9's purity.
Every batch is tested in the lab. Purity here is not a guess, it is measured.
Only when impurities fall below a few parts per million can it be called 99.99%.
The result is pure gold in granule form, ready to be melted one final time.
Now, that purity is locked into iconic shapes. The gold bar.
Pure gold granules are melted in crucibles, forming a glowing liquid metal.
It moves like lava, yet this lava is worth millions per ton.
Carefully, workers pour the liquid into molds, each one a future bar. A few seconds decide the bar's final shape and surface. What drops onto the table is not yet perfect, but it is unmistakably gold. Cooling locks the bar into solid form as steam erupts around it.
Edges are ground and polished to meet strict physical standards.
Then, identity is pressed into the metal. Refinery mark, weight, and purity.
Those 4 digits, 9999, are the refinery's promise to the world.
Each bar carries a serial number, making it traceable across borders and decades. Assay cards and certificates accompany smaller bars, adding another layer of trust.
Weight is checked with precision. A fraction of a gram can mean thousands of dollars.
Finally, the bars enter vaults, silent rooms where value waits in the dark.
This journey, from rock to 99.99% bar, takes enormous energy, time, and risk. This journey, from rock to 99.99% bar, takes enormous energy, time, and risk. Bitcoin's story begins not in a mine, but in buildings like this.
Inside, instead of shovels, you find machines built to solve math problems.
These specialized computers, called ASICs, do one task: hash as fast as possible.
They draw massive amounts of electricity, turning energy into digital scarcity.
Every second, billions of guesses are made to find a valid block.
A block is like a sealed page of transactions added to Bitcoin's public ledger. As more miners join, the network automatically increases difficulty to keep blocks rare.
When a block is found, the miner receives newly minted Bitcoin and transaction fees.
Unlike gold, you never touch this reward. It appears only as numbers on a screen. Secure storage replaces vaults. Seed phrases replace metal keys.
Instead of one refinery, Bitcoin has thousands of nodes checking every new block. But this digital gold comes with a cost: heat and energy.
Power plants feed mining farms, linking electricity directly to issuance of new coins.
Some sites reuse stranded or renewable energy, trying to reduce the environmental impact.
Gold's purity can be tested with machines, acid, and experience.
Yet fake bars exist, filled with cheaper metals under a golden skin.
Bitcoin's authenticity is checked by thousands of nodes, following the same rules.
To fake a digital bar of Bitcoin, you would have to convince the entire network.
Ownership records can be private or written into public ledgers for anyone to see.
Security looks different. Vaults and guards for gold, seed phrases and backups for Bitcoin.
Bitcoin allows a different model. You can be your own vault, for better or worse.
Since launch, the core Bitcoin network has run with remarkable uptime.
Gold, meanwhile, has survived empires, wars, and currency resets.
For a new generation, the question is not gold or Bitcoin, but how each fits into their future. As inflation, technology, and trust shift, so do our ideas of what safe really means. Gold will likely stay a symbol of solidity, weight, and permanence.
Bitcoin may continue to grow as a tool for fast, borderless payments and savings.
Both industries face pressure to clean up their impact on the planet.
For many, the answer is not choosing sides, but understanding both.
One shines under light, the other shines in code.
In the end, the real gold may simply be what enough people agree to trust. From mines and refineries to servers and algorithms, our idea of wealth keeps evolving. The real question is not which gold you choose, but whether you truly understand how it's made. The next
Trust is enforced by rules written into open source code, not by a refinery stamp.
A simple string of characters can represent a fortune, yet weigh almost nothing.
Bitcoin's value is shaped instantly by global markets, 24 hours a day.
Two creation processes, two kinds of scarcity, one in matter, one in math.
Physical coins are just symbols. The real asset lives in the ledger.
Gold is heavy but stable. Bitcoin is weightless but volatile.
Bitcoin's story is young and dramatic, rising and crashing within months.
Gold has a history stretching back thousands of years as money and jewelry.
Gold demands secure vaults and physical transport. Bitcoin travels at the speed of the internet.
Both have environmental costs, whether in chemical waste or energy consumption.
Gold has practical uses in jewelry, electronics, and even medicine.
Bitcoin's utility is digital, moving value without asking banks for permission.
Nations hold gold as a reserve asset, a backup when trust in paper money fades.
Bitcoin's rules, on the other hand, are open for anyone to inspect, but not to change alone. For investors, the choice often comes down to temperament, safety, or possibility.